So suppose we have this situation where we've got a map and we're considering what happens when the map acts on a point z0. Now suppose we have these conditions. So this is quite general. If n is 1, then this simply means that it's an ordinary point where the derivative is not 0, so it should be conformal. But we also have other cases where it's a critical point as the first derivative is 0. So what happens? So, or what we're trying to show is that the angle through which gets mapped to the angle between two lines intersecting z0 gets mapped to two lines which have an angle of n times what happens at z0. Okay, so we're going to call w0 just f of z0. And then what we're going to do is we're going to consider we've got z0 here, and then we consider this point here, which I call z0 plus delta z1, and this point here, which I'll call z0 plus delta z2. Okay, so delta z1 and delta z2 are very, very small, so I can just, and the angle between them I'll just call theta for the time being. And then this is going to get mapped to, on the w plane, to w0, and this gets mapped to w0. This point here gets mapped to w0 plus delta w1, and this point here gets mapped to w0 plus delta w2. Okay, so we want to know what happens. What's this angle here? So what we do is we consider the Taylor series. So we say, well, w0 plus delta w, and I'll just use subscripts. J is best to use in complex with an I. Delta, where j is 1 or 2, is going to be f of z0 plus delta zj. And then I just expand this using the Taylor series, which I'm allowed to do, Taylor series, because it's analytic. So I've got f of 0 plus f dashed of z0 times delta zj plus f double dashed z0 times delta zj squared over 2 factorial plus, and so on, until eventually I get plus, the important term in the end is actually fn over n factorial, and then so on. Now what we've said is that this is 0, and all of these things are 0, so all of these things go, and we're just left to if we then subtract this, then we end up with delta wj is equal to plus order delta j to the n plus 1 plus the next term. Okay, so we've got delta wj, so j is 1 or 2, is equal to this expression. So if we want to find the angle between these two things, well, all we do is, well, we can just divide one by the other, and that will give us the angle between them. So running out of room. Okay, I'll get rid of this. So let me, rather than call this question mark, let me call this theta dash. This is the thing we're trying to find. So theta dashed is the argument, well, we can think of it as the argument of, the simplest way is actually just to do the argument of delta W2 divided by delta W1. If you remember, this is the case because delta W2 we can write as, let's call it R2 times e to the I theta 2, and delta W1 is R1 times e to the I theta 1. When I divide those two things, the argument of the thing I get is theta 2 minus theta 1, which is what I'm trying to find. So I'm going to get theta dashed from the argument of W2 divided by W1. If I divide those two things, I'm dividing this when z equals 2, when j is 2, by the same thing when j is 1. So everything cancels, this cancels, this cancels, except for this. So I end up with the argument of delta z2 divided by delta z1. But this is all to the power n. So now the argument of a complex number raised to the power n is just n times the argument. So this is equal to n times the argument of delta 2 over delta z1. And this we said is equal to theta. So we end up with theta dashed is equal to n theta, which is the thing we're trying to prove. The conformal case is when f dashed is not 0, n equals 1, and we've proved that as well.